Hello, good morning, good afternoon, good evening. Welcome to everyone from all around the world, and thank you for coming along to today's session. My name is Stu Pringle, and I'm your host today, and I'm going to be joined by Nick Howard from Empire Engineering and two specially invited guest speakers, Marc from Siemens Gamesa and Colin from ITH Bolting Technology. Today's discussion, the title is Big Bolted Connections, is the industry ready? My goodness, we've got lots and lots of people coming along today. Hello everyone, I can see you all saying hello down the sides. Hello Narasim, good to see you. Okay, so we know this is a hot topic and we're all looking forward to the debate. But first of all, just a little bit about who's putting this on today. Empire Engineering is an engineering consultancy that supports the offshore wind industry with advice, insight, and technical know-how. We're headquartered in Bristol in the UK, and we also have a London office. And as a team, we can be deployed all around the world. Okay, before we get into the session properly, just a little bit of housekeeping. Many of you joining are now regulars and know the score. If this is the first of our tech sessions that you have come along to, first of all, where have you been for the past few months? But now that you're here, there's a few things that are useful to know. You can see there is a chat forum down the right-hand side. So please say hello, as lots of you are, which is great. We'll also be sharing our screens during the session, so you don't need to do anything. You can just sit back and enjoy the session. If you do have a question, you'll see at the bottom, ask a question. You can pop it in there and we will pick it up. And we're also going to do a couple of Ask the Audience moments with some polls, which we'll switch on a little bit later. Right then, before we meet the speakers, I'd just very briefly like to say thank you very much to our sponsors, ITH Bolting and Wood Thilstead, who have made the whole series possible. So thank you very much to both of them. So today we're talking about big bolted connections, and I think it's probably about time we met today's speakers. So I'd like to introduce you, first of all, to Marc. Marc, good morning. How are you?
Yeah, quite good. Nice being here. Thanks.
No problem. Thank you for coming along. And we've also got Colin. Colin, good morning.
Good morning.
Good morning. And last but not least, we have Nick, who's now a bit of a regular on the tech sessions. 2 months in a row, Nick. How are you feeling about that?
Yeah, I just apologise to everyone who's had to look at me every Friday for the last 2 months or whatever it is.
Very good. Well, it's only a quarter of the screen. Okay, good. Right then. Now we're all here and the audience is all here as well. Let's get started. So perhaps we should set the scene. Let's start gently. What do we mean by a big bolted connection? What are we talking about here? Nick, go on, you start.
I'll start. I think so. I was thinking about this last night. What we mean by big bolted connections and how I should lay the scene, set the scene for this discussion. And I was kind of thinking that the bolted connection, if you will forgive me a tenuous analogy, is a bit like my own career. So we kind of when I started, there was the old school sort of grouted connections, which I kind of see as the baby boomer generation of connections. So they kind of came out of the oil and gas industry. And then I came along, the sort of the millennial. I see that the bolted connection very much as the millennial in the generations of connections, and that for a while we were kind of the new upstart or whatever, and as time's gone on, we've got a bit older, and my knees have stopped working once how they used to, and I think we're seeing some problems in a similar fashion with the bolted connection as we're pushing these connections further, and now there's kind of the next generation, if you want, the generation Z of connections. So we have things like slip joints and TPS foundations, and different fancy technologies coming to the fore. So I see the discussion now is whether do we still have relevance, or are we going to go are our days numbered? Is the days of the big bolted connection numbered as we push them, as turbines get bigger, as loads get heavier, fatigue loads in bolts increases, difficulties with installation, deeper foundations, what have you. Is the flange, is the bolted connection up to the job? And, is it here to stay, or is it kind of a flash in the pan?
Okay, interesting. Thanks for the philosophy there, Nick. I like that.
I thought, Why not? Why not? It's a Friday.
Excellent. So why have bolts become the popular choice? What's sort of the situation there?
Colin, shall I let you?
Yeah, I mean, I think when you look at, really, for me, the main differences between, or I can see between bolting and grouted connection. A grouted connection is something that's, very difficult to inspect, whereas a bolted connection can be easily inspected. You can even disassemble it, replace the bolts if you need to. I think this is one of the major differences.
Okay. Mark, anything to add on this bit?
Yeah. I think if you look into the history, I mean, the grouted connections, they could have worked well, but some things went wrong. And then people got afraid and they changed to bolted connections, maybe a bit naively thinking that they are all very well proven and there's no issues with bolted connections. By now, people have realized that bolted connections also have some challenges, that they are not necessarily, let's say, pain-free. And we have gone through all the sizes. When I started, M36, now M72, M80. And we are pushing the boundaries, bigger sizes, larger load. We are obviously getting to the limit. So the L-flange connection is not going to carry us.
Yeah, I mean, when you look at bolted connections, you've got to consider the difference between, obviously, what everybody considers the standard, the HV bolts up to M70, which, they're not good enough to give you the desired preload within the joint. And then you have specialist fastening elements, tensioning elements, like we have at ITH, where, when you look at the joint itself, the HV bolts were developed for building bridges, taking shear loads. The tensioning elements are actually designed specifically to hold loads under tension. So these are dedicated fasteners really for this application. I can't speak for the whole industry. I can only speak for ITH, but we've got M80 already coming out. It's here. I mean, it's coming to an MPTP near you very soon. But from our point of view, we could offer up to M100 in a 10.9 grade fastener fairly easily. We'd only have to go through further approvals. Making the fastener, the technology, and the materials are all there. So you can say bolting has had its day, but if you consider an M100, that's probably going to take you up to 25 megawatts, who knows? But certainly it's going to last a few more years.
If I offer that to my construction people, then they won't be happy. That I know for sure.
Okay. But
I think you touch on something in terms of kind of going beyond the M72, just in terms of kind of deviating from the standards and norms that everyone's kind of designing to. I think there's a kind of industry-wide discussion to be had about, are the standards kind of reflecting the current practice or the current technological capabilities, or is there a kind of, are they out of step? And Mark, I think I'm going to point the finger at you, and
Mark is
there's some responsibility, some blame. For standards.
All of the blame is on me, not all of the blame, I would say, because it's a very ironic situation that the HV bolts, it's an ancient German standard. For some reason, they have been used in wind turbine towers as well. So when I started, they were already around, but they are by far not the best solution that we could get. So actually, they have quite some disadvantages. But we keep on using them because that's what in the codes and standards, and particularly in Germany, if you're outside of the DIN standard, you have a hard time. So that is certainly something where we would need improvement, or where we simply need to maybe write our own standards in the wind industry to overcome that.
Interesting stuff. I think it's about time we ask the audience a question. Why don't we find out what our people think today? So everyone, right. We have just opened a poll at the bottom of the screen. If you see at the bottom, it says polls and it's a number 1. If you click on that, you should be able to see that we are asking you today, what type of connection, which connection type do you prefer? We've got a lot of people online today. There's a lot of people watching. So let's see what results we get. And Colin will be pleased to see that early bolted into the lead is bolted.
Can we keep it for 20 years, until I retire, huh? 20 more, maybe 25 actually.
And what I quite like, we've got Carl Winkle, who's been part of this before, giving us his view as well. So apparently we're all not strong enough to lift these bolts. So thanks for that.
Grouted connection doesn't have a lot of lovers, so aren't there no fans of the grouted connections outside?
Who would? You'd have to be crazy. There are three people who clicked the wrong button there, I think.
So there we go. I'll let it run just for a few seconds longer, but it looks like Bolted is in the lead.
Yeah.
48% of the vote.
Votes are stabilizing.
I think, Stu, maybe instead of phrasing the question, which connection type do you prefer, it should have been which is the least worst. That's my...
Wow. Well, I think let's pass it back to the designer for a moment. Yeah. Nick, come on, what's happening? You've talked a little bit about tolerances and things getting bigger and loads. Come on, what's happening?
Yeah, I think... I mean, a connection is always a tricky interface. There's no kind of doubt or getting around that. It's, you know, it can drives a lot of things. You know, it's governing in all sorts of analysis parameters. But I think, especially when it comes to bolted connections, there's kind of almost what we've touched on already with the mismatch between the standards. But I think there's a mismatch between maybe all the parties involved, kind of along the project chain. So as a designer, you know, there are the standards we have to work to, but then maybe there are, you know, we can see some deviation is required to get the connection to work, and often this comes down to the waviness tolerance or the run out tolerance of the flange, and you know, we're doing a lot of analysis to try and justify maybe having a greater waviness or something like that. And then that ties into the fabrication process. As these flanges get larger and larger, the capabilities of the fabricators are kind of starting to be pushed, or, you know, with especially as diameters increase, the kind of the machining capabilities and the ability to limit the kind of the post welding distortions is really tried. And but yeah, being able to be a designer whilst respecting the capabilities of the fabricator is turning out to be really challenging, and every project, it seems, you know, that boundary is being pushed further and further, and it gets harder and harder, and, you know, you keep on having to go to your box of magic tricks to kind of find you know, some bit of the code or some FEA analysis you can pull out to kind of justify and get it all to work. Yeah, I think something's going to give at some point.
Come on, we can't let Nick have it all his own way. What do we think to that?
I mean, it's fair to say that the tolerances are really strict, and they have been devised almost 20 years ago. So that was based on onshore towers, 4.3 meters diameter max, 20 mil wall thickness maybe. And I've heard that question a lot, of course. Shouldn't we not adapt the tolerances? Shouldn't they be proportional to the diameter or like? And I set out in 2018, it was to investigate whether I could justify actually going to larger tolerances. And I made investigations which ended up in a paper which has been public end of 2018 about tolerances. But the frustrating thing was I found the opposite. So I actually found that we could not increase tolerances, but we should actually even make them more stringent, because the large wall thicknesses that we are facing at today's towers and MPTP connections simply makes it harder for gaps to close. In essence, that in the end means that maybe we even need to have stricter tolerances today than we had in the past.
Mute him.
I mean, from a bolting point of view, but the designers, I mean, is there not scope to look at maybe different designs of flange as well, rather than having this big inclination in order to keep the outside watertight? You can use flat flanges with seals, for example. Are there other approaches that could, you know, make it easier, not just for the fabricator, but for the whole bolted connection?
I think the difficulty comes with modifying the flange especially when you're talking about like an MPTP flange.
Yeah, that's what I'm talking about.
Yeah. If you're driving on the MP, then obviously you kind of need an inclination on that top face to avoid the hammer strike and kind of making your flange vibrate. And I can only see that becoming more of an issue. And I think someone in the chat, Ferdy, mentioned TP-less solutions. Obviously, you're still kind of obviously, yeah, that removes one connection, but you're still then driving on your foundation tower connection. And
with a huge amount of weight.
Yeah, as diameters get bigger and water depths increase, then kind of the hammer energy you're putting into your flange is only increasing. So it's almost getting worse, and the possibilities for modifying the flange become a little more difficult.
And the inside inclination actually does have advantages. I mean, one of the countermeasures to actually work against the waviness and the gaps is then to do shimming. It's an old-fashioned method, but it works. And you, of course, you need the inside inclination also to have your inside axis for the shimming. And part of the difficulties in really finding a good solution for this is that this inside gap is closing really quickly. The inside gap is closing really quick because you only need to rotate the flange, which uses much less force compared to closing the outside gap, the one that is really critical.
Yeah, of course.
Yeah, Mark, I think shimming is an interesting one because I've been in kind of design meetings where whenever anyone says we could just shim it, it's kind of panic stations from everyone, and no one sort of trusts it or no one believes in it.
No reason for that. I mean, shimming works. That has been proven numerous times by scientific papers. Also, 20 years ago, I did some tests on a flange which did have large gaps, and we shimmed it and we measured bolt load forces, and they were perfect afterwards. So I don't see a reason to be worse against shimming, and for us, that's currently the main countermeasure to actually let's say, make sure that we do have a stable connection, even if we have large initial.
Understood. Okay. Just bringing back to sort of the initial kind of question that we asked at the start of this, and Colin, you've alluded to it a little bit as well, that M72 doesn't need to be the largest. Things could go bigger.
They have gone bigger already. I mean, M80's coming. You'll see that you'll see it actually deployed in the field within the next 2 years. But in terms of being designed into foundations, that's already going on more than one project. I can't give you specifics, but it's becoming the norm now that you have these bigger turbines, starting with the GE Alliad, but Siemens Gamesa are soon going to trump that with their even bigger turbine, and these will all require, I suppose, M80, to get a foundation that's strong enough with enough bolts in it and able to resist the bending loads and get enough load into the joint itself.
Colin, sorry to interrupt. How are the larger bolts handled? From an installation perspective, obviously the weight.
I mean, I don't want to get into a sales pitch with ITH, but I can describe how we do it. I mean, and we are, we've got nearly 1,000. Well, we will have 1,000 MPTP bolted connections in the field. So, we have the most experience, let's say. The bolts are all actually pre-assembled before sail out with our system because we're using a tensioning system. So we're getting obviously all the mechanical advantages of that compared to torquing. But we use stud bolts. So you're able to assemble with a sleeve on the flange of the TP. You have the stud with a nut on the top and nothing on the bottom. And this is held in place by a plastic sleeve. And then when they position the TP onto the monopile, it's just a case of, once it's in position, the technicians just walk around and pull the sleeves out, boom, 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 and all the fasteners slip in. So any handling that's needing to be done, that's actually done on shore before the sail out. And in terms of getting the fasteners in place, we've developed handling solutions, carousels, and so on. M80 is going to be a bit bigger. If you went up to M90, M100, then okay, you really need to have something to handle it, but it's hardly an insurmountable challenge. I mean, it's quite basic engineering. We've already got experience of it. There's any good materials handling company will come up with a solution within a very short period of time. That's not really the challenge. I don't see that.
Right. Colin, I think that's a good time for us maybe to ask the audience again. Since the last poll seemed to generate a lot of controversy, as all polls do these days. Why don't we have another one? So, second question today. Ask the audience, everyone. Do we feel that M80 and beyond is the right step for the industry? So if you just wait a couple of seconds, that poll should pop up in the poll screen. If you scroll down, if you open the poll box and scroll down, you'll see it's below the first poll. Does the audience feel that M72 and beyond is the right step for the industry? Here the votes are being cast. Interesting. A little bit more. Ooh. So we had early on, we had yes in the lead, but no's come rushing back. Interesting. Comment there about scope for larger turbines. So it's pretty even, this one.
Yeah, even with not sure. It's rare that the kind of other option gets.
Yeah.
When are we counting the mail-in belows?
Dave, this has not been declared. It's interesting though. It's certainly there isn't consensus here, is there? You know, usually there's a clear winner when we ask the audience, but this one certainly feels a bit.
That's an interesting one indeed.
Yeah, I think that mirrors my own kind of feelings on the topic. Yeah.
Tell us more, Nick. What do you mean?
Well, are we ready? As I see it, there's I think the you know, as a personal preference, the bolted connection is kind of my least worst one. So I'm kind of all for it, and I want it to go forward. But I see with every project kind of a new hurdle put in front of going for it. And Colin, you mentioned you know, ITH's kind of capabilities with larger bolts, but it's difficult kind of at an early design stage to go for like a proprietary fastener or you know any sort of item you can source only from one place. And
it's not proprietary though, Nick. I mean, people have this opinion, but you know, there's an ability to go and source the bolt independently, and customers have done this in the past. So it's not a case of, I mean, we're a bolting equipment manufacturer who happened to design a fastening system because everything that was on the market wasn't good enough to work in these applications, specifically with the wind and the offshore wind. So we only designed it because nobody else would. There's no necessary. It's not proprietary. There's no need to just say, okay, you can only buy that from us. And we don't see it as the market grows. I mean, even where the market is now, we wouldn't have the capacity to supply every single thing anyway. If, you know, so it's in our interest to have suppliers also. Other suppliers supplying the fastener.
I see a question in the chat from Stefan about is the supply chain ready for greater than M72?
Yeah. I mean, the supply chain is certainly ready. ITH. I mean, if you're looking at beyond 10.9 bolts, I mean, we have fasteners that regularly up to 200 M200, so up the M160, M180. Common in the gas and steam turbine business. I mean, we have bigger fasteners than that, but there are enough suppliers to satisfy the needs of the market as it stands.
I think it's fair to say that it can be done. Of course, we can even go larger, but no one really wants to make that step. Kind of related to the question of the diameters, we are also in a situation where we just of the connection capacity. We sometimes need to increase the diameters. It's also not the preferred way of doing it. But if we want to stick with the traditional flange connection, we simply need to go for a larger diameter, or we need to go for a much larger size than an M80. Maybe go to M100. But that's essentially maybe not the right thing to do, which is also why we are of course looking at alternative options in order not to make the connection be the driver of the whole support structure and diameters and everything.
There's another thing that we see. I mean, the industry in principle is kind of taking an approach that tensioning is being seen now as, you know, the method of choice for large diameter bolting. And if you can design that into your process, I mean, with the tensioning, what you can do, you can move the bolts closer together. So you can get, you know, 10, 15% more bolts on the PCD for a start. That helps you achieve your load. You can also move the bolts closer to the flange wall, you know, reducing your bending stresses essentially. as a
It all
result.
helps, yes.
And if you can design with tensioning from the beginning, you can also save material in the flange because it doesn't have to be quite as big. But what's happened in the past and what currently happens is that the designers think, well, we don't know what the installation method is going to be, so we have to design it with torque and tension in mind, and you end up losing the benefit because you don't design the bolts as close together as you can, so you don't get as many on the PCD, you don't get them as close to the wall, and you don't take advantage of the material savings. But I think what we're seeing now with the M80, because it's pushing things to the top end, the engineers like yourself, Nick, you're trying to get every last horsepower out of the engine that you can. The industry now seems to be accepting that we've got to do this. We've got to design with the tension. We've got to get as many bolts in as possible into the PCD and move them closer to the wall. Otherwise, you'll be asking for M100 tomorrow.
I think that's really good insight, Colin. I want to move on to the questions in a moment, just because we've had a few come in. But just before we do, could we very briefly just touch on inspection and sort of on OPEX costs? Because one of the things we found last month is that there's a general belief in the industry that too much focus is played on CapEx. But of course, there's an OPEX conversation to have here as well, isn't there?
Yeah.
Absolutely. I mean, we see us... From ITH point of view, we see our system and what we offer being able to save probably more in OPEX as it does in CapEx. And our whole philosophy is pushing towards maintenance-free bolting. So with the tensioning system, with the dedicated tensioning elements, you can easily get your enough preload to be way above the 70% dust 021 window. And then when we combine this with other technologies such as semi-automatic bolt tensioning, where the system measures the elongation on every single fastener, so hence you can extrapolate the preload from that, and also has like a fail-safe system that guarantees and record everything documented as well, guarantees that you have actually installed the fastener correctly. With that, combined then with some time of flight measurement that you need for lifetime monitoring, you do end up with a maintenance-free system. And rather than having to lug, 500-600 kilograms of equipment offshore to retighten things after 500 hours every year and so on, you can simply go on offshore with a device. I mean, it can be done remotely as well, actually, but you just go and quickly measure the preload with a small box weighing maybe 6-7 kilos in total, and it has all the kit in it.
That in the chat was mentioning the human factor, and that is very important indeed to get the human factor out. So we are, of course, also looking into that, and one of the main elements is actually to make sure that there's no room for human error.
Yeah.
Okay.
Only then it would be possible to go completely maintenance.
Okay.
Yeah, you need to guarantee that every fastener has been installed and be able to measure the preload at installation. And if you can do that properly, then you have the confidence.
Brilliant. One quick question just before we jump to the questions from the audience. Putting you on the spot a bit, folks. What do you think is going to come next? What do you think is going to be popular over the next 10 years? Are we going to see return to grouted? Are we going to see bolts? Are we going to see TP-less? What's our feelings?
TP-less will certainly become a more dominant solution, but then we still have a connection from the TP-less to the tower, which is also being challenged. Grouted connections, probably still a few, but not that many. But I'm pretty sure we will see other solutions, novel connections enter into the market, because the standard ELF range is simply not the best solution. My colleague Mark Larsen in the chat was also mentioning that the load path is actually quite crappy. So why stick to it? That's a very good question. So we are looking at solutions which actually are better than the ELF range. We hope that they will then actually enter the markets.
But I think, in the next 10 years, you're not going to be in a situation where you move away from bolting completely. There will be other technologies coming in, but I think bolting will still be the dominant technology.
It will still be bolts, yes.
Engineers are very conservative. Nick, you can maybe have a comment on that. So, people tend to go, engineers want to go with, obviously, tried and tested solutions that they can rely on, that we know are going to work in spite of not being perfect. So I see within 10 years, I think with the bigger turbines, I would put money on there being an M100.
Well, same like a 10-meter monopile. No one was expecting a 10-meter monopile just a few years ago, I guess.
It's coming.
No, I think it's financiers who are conservative and engineers are happy to push things, but we get told off and we get told not to take any risks. So.
Sorry,
that sounds like January's title there, right there, Nick. That's your next session.
But no, I think in terms of the future, for me, I see this as quite a cyclical thing. I think things come into fashion because no one's discovered the problems, and then we'll install some TP-less foundations, and all the secondary steel will maybe have some issues, and then we'll say, oh, maybe that wasn't quite the savior of the day, and then we'll look back at the previous things we used and said, oh well, maybe perhaps better the devil you know, and.
Maybe the grounded connection was not too bad with everything pre-installed on the TP. Yeah, who knows?
I'll never believe that.
There's another technology that we see coming in. I mean, we're driving this as well, of course, but how you close the flange gap and your actual method of bolting. So a system that can go and scan the flange gap on each installation and then quickly calculate an optimal bolting pattern as a result, so that you're closing the gap, and then you're able to tension all your bolts with getting all the preload into the bolts, rather than every time you're bolting you're closing a bit of more gap and losing the preload. Some kind of technology around this will have a big impact in the market.
I think that's it. I think it requires a technological solution. I think the kind of box of tricks is now empty, and it needs innovation on these hurdles and on this new technologies to make the connection relevant for these larger loads, larger turbines.
Yeah, I mean, and that's one of the ways that we're working anyway to help solve the problem you have with the tolerances on the flanges, because you're never going to get that perfect. But by improving other technologies, there could be ways to remedy it.
Very good. Okay, folks. Well, look, the time is speeding in. So, Nick, I don't know if there's any of the questions that have been asked by the audience down the bottom that are worth having a little look at just for the next couple of minutes. And if anyone would like to ask a question, now's a good time just to pop something in. Ask the panel.
Well, several people were mentioning T-flanges, I think, which is also an interesting item. Of course, at the top TP-less construction, we can also use a T-flange. That is sort of the safe option if we look at traditional, well-proven connections. And if that works for driving and everything, then at least at that elevation, it is a traditional alternative, I would say. Henrik was saying that we have an annoying patent on that. I'm not even aware of that, Henrik. Maybe you can send that to
There's the most upvoted question is, what is your take on misaligned bolt holes when assembling the wind turbine towers? Increasing the bolt hole tolerance or anything else?
We are increasing bolt hole tolerances, which does have limits, of course. We are also correcting. We definitely need to be 100% sure that we do not have bolts touching bolt holes when we start preloading. That actually has happened in some wind farms in the past and has led to massive problems. So that has a high focus. But it's the same old discussion on all projects. What kind of tolerance do we need? And kind of the trend is to use increased sizes, at least on one side of the connection, to have a bit more.
Very good. Excellent. Any more?
What's the next one? What's ITH's view on shimming? So I think we touched on that, but we didn't get your input.
What's the view on shimming? I mean, shimming is common practice on all of these installations. So it doesn't impact us. I mean, I've been on mock-ups where I've seen it being done, and I think it appears to be just a standard practice in the industry. As long you're going to have to close the flange gap somewhat because you've got an inclination. You don't shim everything. They calculate how much shimming is needed in certain areas, but yeah, from our point of view, it's just considered part of the process. Does not interfere with the tensioning either.
Go shimming. Mark, I think there's a question I think for you. The matter of M72 and higher is not only concerning the bolts, but also the flange and tower. What's your view on that?
Well, of course, if we increase in size, then we also increase the flange itself. So, and that becomes quite massive. And flange steel is not the cheapest steel, so that's also an argument why we are not really keen on going beyond M72s. So whether that was the question actually?
Yeah, I think yeah. What's the impact on the flange of going beyond M72?
You always need to grow the flange proportionally with the bolt size. And they are quite a massive contribution to the overall tower price already. So the relatively high costs. Definitely don't have a desire to increase that share.
Okay. Thank you very much. Any final thoughts, folks, before we sort of begin to wrap this session up today? Because we're running a little bit over on time, as we always do.
Which is fine.
That's absolutely fine. Very good. Right. So I would like to say thank you very much to all of our speakers for today's session. I'd like to thank all of the audience who have very much got involved. So thank you very much for taking part. A big thanks to our sponsors that you can see on screen there. In terms of the tech sessions, we're going to take a little bit of a break for December. But keep a lookout on email and also on the Empire Engineering website, because we are going to be back with a vengeance in the new year. So look out, probably a session in January. Finally, I'd just like to say that if anyone here would like to talk with the Empire team, you can see the contact details on screen now. But for now, it's time to say goodbye, everyone, to say thank you. And thank you again to our speakers, because I think that's been a really, really good discussion today. So thank you very much. That's it, folks.
You're welcome.
Thank you.
Thanks a lot, guys. Have a nice day.
Bye.
Bye.
Cheerio.